Section 10.6 has to do with solving exponential equations. We've done a little bit of this in the last section, but these are situations where you cannot get the same bases. You know, at the very beginning of the chapter, we solved equations like this where we matched up the bases and matched up the exponents. Well, if you'll notice on here, you can't make 6 and 42 the same. So what you want to do is you want to take either, and you can solve these either by doing the natural log or the common log of either side. It won't matter. So I look here and I go, well, I'm going to take the log of both sides. Now, the unknown is this x. Now, it's an exponent, so I can bring it to the front of that natural log, or that log. Like I said, you can use the natural log on it, or you can use the common log. It doesn't matter. I'm going to divide both sides by the log of 6 because I want to get that by itself. So then I'm going to take my calculator, and I'm going to do the log of 42. Now make sure you close that parenthesis before you divide it by the log of 6, and close that parenthesis, and it's going to give you a value of 2.0860. So that would be the value of x. So 6 raised to the 2.0860 power is going to give you 42. All right, let's do this one. Again, you can't make them have the same basis, but you always want to check. So I want to take the log, or I could take the natural log of both sides. So I'm going to bring the x to the front because it's an exponent. Then I'm just using simple algebra here. To solve for something that's multiplied, I have to divide. So my x value is going to be whatever I get when I take the log of 20 divided by the log of 7. And I'm going to get 1.5395. So that would be the value of x. And you can always plug it back in and check it. All right, here's a few more. Now these are a little bit different because they have more than one value up there in the exponent. But I'm going to do it the same way. I'm going to take the log of both sides, and I can bring that exponent to the front. So I have 2x minus 5 times the log of 8 is equal to x plus 1 times the log of 5. Okay? Now, what I'm going to do, I might not have left myself enough room, is I am going to distribute this log of 8 to both of those. So I have a 2x times the log of 8 minus a 5 times the log of 8 equals a x times the log of 5 plus a log of 5. All right, now what I want to do is I want to bring the x values to the same side. So I have 2x times the log of 8, and I'm going to subtract that one minus the log, x times the log of 5. And then I'm going to take that one to the other side. So I have 5 times the log of 8 plus the log of 5. Okay? I can factor out a value here of x. So I have 2 times the log of 8 minus the log of 5. And then I can get a value for that side. I have 5 times the log of 8 plus the log of 5. And it's going to give me a 5.2144. I can also get a value for this one. So I have x times, and I can do 2 times the log of 8 minus the log of 5. and that's going to give me a value of 1.1072. And I'm going to divide then both sides by the 1.1072. And it's going to give me a value here of, let's see, use my calculator. $4.7095. Okay. All right, we'll come down here and then we'll go back over here and do this side. Again, I'm going to take the log of both sides, but I can take that exponent and bring it to the front. So 2a times the log of 8 is equal to the log of 124. If you take the log of one side, you got to take the log of the other side. I can divide this by the log of 8 because I'm trying to solve for the a. So I have 2a is equal to, and I can get the value of that, log of 124 divided by the log of 8. And it's going to give me a 2.3181. I'm going to divide by the 2. And it's going to give me a is equal to 1.1590. And that would be the value of a. This one, actually, if you look at it close, you could find the same base value for those, which would make it a whole lot easier. So you can do it the way this one's done, or you notice that I can do this as 10 squared raised to the 2x minus 1 power. So I would have to distribute the 2 there. So I get 10 raised to the x plus 2 is equal to 10 raised to the 4x minus 2. The bases are the same, so set the exponents equal to each other. And solve. So I have a negative 3x is equal to a negative 4. X would be equal to 4 over 3. So that would be the easiest way to do that. So if you can find the base value being the same, then go ahead and do it that old way. All right, this one I'm going to have to take the log of both sides again. This one's going to be very similar to that. So I have a 2x plus 3 times the log of 2 is equal to a 3x times the log of 3. I can distribute the 2x plus 3, so I have a 2x times the log of 2 plus a 3 times the log of 2 is equal to a 3x times the log of 3. Now I want the x's on the same side, so I'm going to go 2x log of 2 minus 3x log of 3 equals a negative 3 times the log of 2. I'm going to factor out the x. So I have a 2 times the log of 2 minus 3 times the log of 3 is equal to a negative 3 times the log of 2. Now you know that you can actually take that and put it on the 2 if you want. So I could go the log of 4, because that's what 2 squared would be, minus the log of 3 cubed would be 27, so the log of 27, and I could get a value here of negative point. Now you don't have to put the exponent on it, but you can. Negative 0.8293 is equal to a negative 3 times the log of 2. I can get a value for that. Negative 3 times the log of 2, or I could use the negative 3 as the exponent. It's going to give you the same value. So this is going to give me a negative 0.9031. So I have a negative 0.8293x. I'm going to divide by negative 0.8293 on both sides. And I'm going to get a value here of 1.0890 when it's rounded. All right, then the last part of this particular section just involves calculator use, and it goes back and shows you how you could have done the problems at the beginning of this chapter with a calculator. If I have a log of base 8 of 77, before I couldn't do that on my calculator, but now I can convert them to using, I could either use common logs or natural logs. Here I chose to use common logs. So it's the common log of 77 divided by 8. So I pick up my calculator, log of 77, and again, don't forget to close through your parentheses, divided by the log of 8, and I'm going to get 2.0889. This one set up would be the log of 64 divided by the log of 16 is how I'm going to do that problem. So log of 64 divided by the log of 16 is going to give me 1.5. And then this one would be set up of the log of 63 divided by the log of 11. And that's going to give me a value of 1.7278. Okay. Your homework on this is page 629, 14 through 44 even.